Hello and welcome to another episode of Scartified Engineering. I'm Sprutis, and in today's episode we will be talking about this, the electrogalvanizing kit that I have. It's bought as a kit, and the reason for this is because a friend of mine asked me to sort of tell a little bit about this from my point of view. So let's start with what's included in the kit. So basically this is an extended kit. So we have the power supply, we have a manual, we have the fluid to use for the electrogalvanizing, the cathode which we hang our parts in, we have the anode which is a ball of zinc. These are extra, and then a plastic container which can handle chemicals that can be a bit aggressive, and the purpose is to get either something that looks like this, a bit shiny, like this, almost orange and a bit dull, or like this, very goldy looking. None of these look very stock, and I'm okay with that since I did this. So if we start from one end and then walk across, the power supply. This is Elleman, so I guess it's quite good quality included with the kit. The kit can be bought with or without a power supply. It's 0 to 15 volts. You max that out, and then you have the current, and the current that you select will determine how much voltage you get, and the current that you want is dependent on the surface, the entire surface of this part, or the parts that you are treating. So that will give you resistance, and then you will get the resulting voltage. I've tried maxing out at 3 amps. For the biggest parts that's okay, but for this one, for example, I tried 2 amps, I think, and I actually burnt the surface. So if you don't have the time or try to stress through the process, then yeah, it will go bad for you and you need to redo it like I did. So power supply. Without it, you don't have the electro in the term. And I would maybe call this the main, the lead in this theater. So the fluid which is used. And if we look at the back, it's corrosive, it kills trees and fishes, etc. This is pre-mixed, so I didn't have to do anything about it. I have seen some DIY kits or explanations how to get this. I'm not sure if it's good. This is supposed to be industrial quality, and I think it's working fine. The manual is really good. They actually have nice explanations on how to go about doing this. We will come to that later. This, the cathode. So this is just a threaded rod, stainless steel. It doesn't look like it because of the hydrochloric acid which I've been using before. But a negative cable, so it's color coded. You put it into the post on the power supply with a minus, easy. The zinc anode, it's starting to hollow out in some areas, and I'm not sure if it's the equivalent if you get one of those like boat anodes, the zinc pieces that you can mount on the outside of your boat, for example. I would suspect that this is somewhat different, but in the end, if you are doing it yourself, then maybe it doesn't really matter. The container that we're using and also included in the kit is, like I said, a sturdy one, something that can handle chemicals. I didn't feel like getting something on my own, so I just got this and an extra one. So basically this electrolysis process, with the help of the power supply, will take atoms from the zinc ball to the pieces that are hanging from this rod. And you hang them with a piece of copper wire for good conductivity. And once the process is started, you will actually see the copper wire here getting a layer of zinc on it. And the atoms will basically keep going from one end to the other and build up the layer. And basically the only way to control this layer is by measuring the part. I haven't been that good on that, so screws and things like that are I have to use a tap and a die to clean the threads a bit, cut into the zinc layer. But in the end, after this electrolysis process, we will have pieces like this. Now these washers are made in an industrial way, so it will differ quite a bit. If you want to achieve a OEM kind of result, then you will be able to do so. Here is the piece that I cut off from the feed pipe to the power steering pump. This one is zinc treated and then yellow passivated. And there is quite a big difference between the coloring. And since I know that I don't really will have the patient all the time, I wanted to sort of go a bit extreme with the yellowness and not aim for an OEM way. I want to show that this is what I've done. So then it's easier to just go a bit overboard. But yeah, that's the sort of basic kit, and it will take some time. I try to max out this rod, hanging lots of parts in different layers. And when it comes to screws, for example, you will wrap the copper wire around the thread. You will let it hang in the fluid getting treated for a while, and then you can take it up, unscrew it, or screw it in a bit more in the wire, so that you expose the covered area again, or yeah, just so that you cover the entire part in case it's something that will be visible later on. So once you have covered your pieces with a nice layer of zinc, you might be happy. But that's when you need to make a decision, because every time you do an electrolysis process like this, you are working with hydrogen. So in this case, you run the risk of getting what's called hydrogen embrittlement, which is basically hydrogen that's sort of going into the material, forming small micro bubbles, and that will eventually lead to cracks. And they actually show this in the manual that I got with the kit. So they have a nice picture like that. Now you can argue about how long this negative thing will take, but if you want to be on the safe side, you can actually do something about it. And that's as soon as the pieces are finished, you put them in your oven at roughly, for me, I don't like to go, they say between 180 and 200 degrees Celsius for a minimum of 5 hours. I aim for 175, something like that. If I go any higher, I feel that it takes a bigger toll on the yellow passivization, which we will come to later. But basically what you will do then is to force out the hydrogen out of the part in case there is something. So for example, pieces that are holding on things for your suspension, let's say it's a screw or something that can make you lose a wheel, or make the wheel turn 90 degrees in case it breaks, then you don't really want to run the risk. But if it's like something that holds the valve cover, then it doesn't really matter if it breaks. So then you don't need to do that. And in my experience, this heating process will dull the parts, which is why this nut looks like this. Then we have this one, which is actually kind of shiny. This one have been heat treated. And if I'm right, I made a re-step. So let's move on to the next step, and then we get the middle step. The next step is yellow passivization. This is purely chemical, and it's much faster than the zinc treatment. So what you do is, once the pieces have been zinc treated, you lift them up, shake them off, and then dip them down in this fluid. And then you sort of swing them in the fluids. It's always sort of flowing around the piece, which will make for a more even coating of the yellow. So that one is quite easy to do. And then in case you do that, you do the zinc treatment, you do the yellow passivization, and then the heat treatment, and you end up with a piece like this. But you want it to look like this. That's when the acid comes out. So this is hydrochloric acid, and I've written quite clearly here on this that it's diluted to 15%. So 15% acid, and the rest is distilled water. I don't like acid, so I try to avoid it. And the coloring is because of the yellowness from this. the yellow passivization. So the reason, I think at least, why you need to go directly from the sink bath to the yellow passivization bath is that the pores are sort of open. If you let some time go in between those two and you let the pieces dry, then you can dip them in hydrochloric acid. This will open up the pores again, which will make it suitable to go into the yellow passivization bath again. So that is actually something I've done when either if I'm not happy with the result, I've burnt the surface, or it's too dull, or I'm just not happy with it, then I can do that. So then you don't need to restart. Now on this piece I sort of did restart because I wanted to test the strength of the zinc layer that I got with this kit, and using a bench grinder with a wire wheel, it took some time to get the zinc off this, so I was quite impressed. In the end you will have a piece that sometimes looks good, at least for the person who created them, and that should basically be what matters. But then you have actually a two-step program for protecting the pieces from rust or corrosion. So the zinc layer, that will of course protect the piece from rust, but then also the yellow passivization, even though it's very thin, it will actually act a bit like a protectant against corrosion. So it won't be as good as the zinc layer, but at least then you can sort of motivate the purchase for the yellow passivization fluid as well. At least in this store, so GDS-butiken, Gör det själv, which is the Swedish abbreviation for do it yourself. They sell a bunch of different kits, different sizes. I think this is the small one, so the containers are 6 liter. They can take 6 liter volume, and these fluid containers or canisters, they contain 5 liters of fluid, so then you will have a quite good safety margin between the top edge and where the fluid actually begins. And something that I like to do is basically set up the threaded rod with the copper wire and the pieces before pouring any fluid in, or if I have both containers out, then I might fill one of them just to get the reference on the distance between the edge and the fluid level, and then in the empty bucket I will see how the pieces hang, so that they are not in contact with neither each other or the bucket, or sticks up out of the fluid. All of those 3 scenarios are something that you should avoid. Since I'm a noob at this, I felt quite happy with starting out with a smaller kit like this. Also, it's a bit easier to handle the amounts of fluids like this. You have 1 zinc fluid, 1 yellow fluid, and 1 hydrochloric acid container. There are kits with bigger containers, but then you need more fluid, so it sort of grows exponentially. This size I think it works quite well for the things that I'm doing, at least. So if you look through my Supra videos, you will see that I'm doing mostly fasteners, big and small. So basically, if you get the ingredients to get like 5 liters of each, then you are basically ready to go. For actually seeing how the process is carried out, then I think it's better to head over to the Supra videos and have a look through that. I think I also have a few shorts showing some of the process. But this is sort of the main event. And after, because that's the shortest and easiest one, you basically just let the parts hang. Let's say I'm doing this now. I do the zinc treatment, I do the yellow passivization, and then I let the pieces still on this rod hang and sort of dry. I try to shake off any drip formations, just to avoid having the yellow passivization fluid stagnant in one spot. I think that can lead to some variations in coloring. But basically after that I put them in a towel just to keep it soft and gentle. Then I take it home and I put them in the oven. And then so I put them in the oven before going to sleep. And one time I forgot to wait for the oven to cool down after making dinner. So it was quite hot, and that really ruined the surface. And since they are so freshly treated, I think it's better if they really start at around 180, or not really above that. But after that is completed, so the next morning I turn off the oven and then I just go to work. So I let them cool down in the oven. Or if someone needs to use the oven, they can just take the pieces out. And then it's done. Now, the thing that will affect the result the most, like anything, painting, welding, this is preparation, of course. All the pieces that I have, all the screws and such, have been sandblasted. And to remove gunk and stuff like that, I've used a wire wheel. But the tricky thing, if you, let's say you only use the wire wheel, then you get the shiny part. And when you hang a shiny part which is getting coated in something that's shiny, then you really need to measure let's say the diameter or something to see how much you actually put on. So if you are a bit more like me and like to do this quickly, then it's easier to start with something that has a dull surface, which will then become shiny. So then you can just use your eyes and see, okay, this seems okay. If it's been in for an hour or two and it looks really shiny, then it's probably done. Then you have sort of a clean part. After that, I've actually used paint thinner to remove any skin grease or grease in general, to degrease the surface. You can use other types of degreaser. I have another container and bathe them in that and so on. But this seems to work okay for my goals, at least. What you can do is use the acid. So basically you sandblast And once you're happy with that, wire wheel or not, dip them in hydrochloric acid. And what I forgot to tell you, so before going from the hydrochloric acid to the zinc or yellow passivization bath, you need to dip them in distilled water to rinse off the acid. I just have a smaller container that I just can, then it doesn't really matter if the pieces are touching the walls of the container or anything like that. Just dip them in and make sure that the acid is gone. Then you can move on to the next. So that's another way if you feel comfortable with always using acid, which I don't. So then I use the paint thinner instead. Another remark is the cables used. So these are marked for 30 volts at 6 amps. So they can very much contain what this power supply can put out. Some other things, when you're cleaning the parts, if you're using a degreaser, then you can put in like a small heater, fluid heater of some sort, to speed up that process. When you're doing the zinc layer or treatment, then the reason why it gets burnt when you're using a high amperage is because it gets hot. So you can actually cool down. Let's say you take this container and put it in a bigger container, and this container outside have, I don't know, ice water or something like that, which cools the zinc fluid. Then you can increase your current. If you don't have the time, then that's one way to go. In the industry, they must be regulating the temperature of the bath, I think. I guess that makes the most sense. But yeah, that's basically what I have to say about zinc treatment. And if you think I've missed something, then I can do a follow-up on that. But and if any one of you have anything else that you've seen that you want me to talk a bit more about, then please write in the comments, and I will be more than happy to do an extra video about it. And I'm sorry for my voice. I had the flu for 3 weeks, and then food poisoning. So yeah, I'm not fully recovered, but I couldn't stay away from the garage anymore. I had to come here and do some videos. So I thought that this was a good way to start up my healed self. So yeah, hopefully this answers your questions. So thank you very much for watching. Please like and subscribe. Stay safe. Take care. Bye bye.